It is important to really make sure that we create a representative reservoir fluid. Okay, so at the moment we are simply mixing the gas, the water, and see what's happening. But in reality, we need to make sure that we are actually capturing the conditions at the reservoir. And we know that the reservoir conditions then must, in that case, the water and the gas now will be in equilibrium with some solids, right? Could be cementing materials, it could be the calcite, it could be barite, it could be some other mineral that that reservoir fluid is in equilibrium with. So we need to account, we need to calculate that. We need to make sure that now we are going to create a representative reservoir fluid. How do we do that? We simply bring the brine and the gas. And now with that amount, with those amounts, we are going to create an object in the software. It's going to be a saturator, where we are going to equilibrate brine, gas, and the respective solids in the reservoir. Okay, so how do we do that? We simply we do that using the saturator tool in the software. Okay, so what we are going to do next is please save. And the next step is we go to the Actions pane and add a saturator. Okay, so double click on the saturator. And before we go to the break, let me just click on here, not click, change the name to Olympus Reservoir. Okay.
Anna, just a quick one regarding the actual scale types, the all and expanded. If the inputs are there, will the model predict precipitation of normal or LSA type scales, radioactive isotopes, such as radium sulfate?
You mean some other scales that are not the standard oil and gas scales?
Yeah, naturally occurring radioactive material, things like mediums, that they sometimes co-precipitate with barium and strontium sulfate.
Well, I want to answer to that. Say yes, but it will, if you have it as an input. So if you go to your Olympus brine, right, and if you have some radium, and you enter it as an ion here, then the software will know that that is in the chemistry. And if we have that solid, if we have regressed that specific solid scale and the co-precipitation and all of that, the software will let you know if that will precipitate out or not. But that's a good question about the radium. I know that I'm not 100% sure, but I know we have worked with some radioactive. I know that some radium scales have been included in the software. I don't know which ones specifically, but I will find out as well for you.
Thank you.
But all of that, as long as you put it, as long as you enter the composition in your brine, then the software immediately will recognize that solid could potentially form. And what you would need to do, if you go to the Olympus production and you go to the solid, you will go to either the expanded or the all and look for that specific solid and select it so that the software can let it precipitate out for you. And then it will tell you how much of it will form. But since it's not a standard oil and gas scale, it will not appear in this list. You will need to go and look for it in this long list. Okay. So, but I'll find out. So you said radium carbonate? I want to
sulfate.
Radium sulfate.
Sulfate. Okay. I'll find out about it. I'll find out
Thank you.
about that specific component. Okay. Cool. That's a good question. Let me just continue. I'm going to stop my video again because I feel like it takes a lot of bandwidth. So
I'm sorry.
Sure.
Can I just ask a question about the plot where you added the gas?
Sure.
Because can I see it again? Because I don't think I had the exact same plot. Yeah. Here you removed the Y2 axis, right?
You
and
have
I cannot have the.
You may have this one, right?
Yeah.
Yeah, this one is going to show you the you save the prescaling and solid plot. So in here we are just showing the relevant scales that the ones that are actually forming.
That's the same.
Yeah, that will be the same. This will be the data that we created in the plot template manager. You can go back to the default just by hover over in the default plot. So you
now we have
So you just
this is
don't
with
have
the gas.
Yeah, you don't always have to go variables and all of that. You can just go and the one that you need.
Okay, thank you.
Life much easier. Okay. Great questions. Okay, so we were talking about combining the brine, the gas, but now we need to make sure that we understand what's happening at reservoir conditions. Reservoir conditions will have some solids. They will be in equilibrium also with that gas and with that brine. And we need to account for all of that. To do that, we will use the saturator tool. And we have already added it here, and we named it Olympus Reservoir. So this is very familiar. It should look familiar. This is very similar to the Olympus production input. You're going to select the type, the name, and the flow. And in here, we are going to do the same. We're going to bring the brine and the gas, put it together, and bring it to the reservoir conditions. So we're going to mix it and bring it at the reservoir conditions. So we are going to go to type and select brine. Software knows that you have created an Olympus brine. So you select that one, the only option there. And then you add 200 cubic meters per day. That's the production rate. Then you have as a gas. So you look for the gas option here. And it knows that it's an Olympus gas. You bring it here, the unit standard 1,000 cubic meters a day. And we said that that was 250 standard 1,000 cubic meters a day. That is the flows. Those are the flows we're going to bring to reservoir conditions. What are the conditions at the reservoir? We need to make sure that we enter temperature and pressure. The temperature of this reservoir is 125 degrees C, and the pressure is 275 bar. So you should enter these values. Okay, so if you click, let's say, on the Olympus brine, you see down here all the components that are being, or the chemistry that is being exported from that brine. And if you click on the gas, you will see the components that are being exported, not imported from the gas and the composition. Okay, so those are the inlets. We want to saturate this at reservoir conditions. So the next step in a saturator tool is to go to the solid tab. Okay, so we have this solid tab, and we should be familiar with this already. We have, but in this reservoir, now we have an extra step to do because we want to account for the saturation of certain minerals or the equilibrium of some minerals at reservoir conditions with my fluid. So we have two sections. We have the solid selection that we are familiar with by now. And we have the reservoir mineral saturation section. So I want you to go ahead and click on the standard here. And we are going to calculate without doing any saturation first. We are not going to do this calculation. I just want to show you what happens, or we want to see what is happening at reservoir conditions without saturating with any minerals first. Okay, we want to benchmark. We want to see what is the chemistry at reservoir conditions. So we click on the standard solids. The software, of course, is telling me you are not selecting the minerals, the solids to saturate, and that's okay. I just want to see what the software will tell me, will calculate if we don't saturate with any solids yet. Okay, so we will calculate, click on the calculate button. And then we will go to the report tab. So why am I doing this again? Is because I want to know first, what is the composition of, what are the prescaling tendency values? What is the composition of the brine at reservoir conditions? Okay, so in here, if we go to prescaling tendencies, we see that nothing, absolutely nothing is saturated here. Maybe we have the barite is at 84% saturation, close to saturation. So we could argue that we can saturate with barite, this fluid at reservoir conditions. And let's see what other one. And another one that I see close to 1 here is calcite. Okay, so calcite is 63% saturation. So this means that possibly calcite could be also at equilibrium at reservoir conditions. So we could argue that we can saturate this fluid with these two minerals, with barite and with calcite. So let's go back to the design in the solid section. And now what we're going to do is going to select the solids that we are going to make, or that they're going to be in equilibrium with the fluid at reservoir conditions. So how do we do that? So down here, there is a section that says mineral to saturate. So we are going to select, first we're going to select the calcite. Let's say we have, a calcite cementation in the reservoir. So we look for calcite here. And the next step, this is important, just click on this yellow, in this yellow cell, so that it brings automatically the inflow to vary. So what the software is doing here is that in order to saturate the fluid with calcite, we need to vary, or the software will vary the amount of calcium in the water, and it will vary the amount of carbonate in the water. Okay, we cannot do it ideally. Ideally, it will be nice if we could just simply move the carbonate concentration, and we don't have to deal with changing the calcium concentration in the water. But we need to make sure that we have an electroneutral water. So we do it in a molecular form so that we don't change that electroneutrality of the water. Okay. So that's the reason why we enter it as a molecule. The next step is to select the other mineral that could be at equilibrium with the fluid at the reservoir, and is the barite. So we can select the drop-down arrow and select barite. Click on the yellow cell, so it automatically brings barium sulfate. Okay, again, the software will remove or add barium, and will remove and add sulfate ions in order to make, just to make sure that you will saturate the water with barite. Okay. And that's it. That's all what you need to do in this saturation section here. You notice that now the software is not complaining anymore. It's saying, okay, you are doing all your putting all the requirements here for saturation. So we can go ahead and calculate. Any questions about this? Let me see. Okay. So once the calculation is done, I always like to save. And then we go to the report. And we have seen similar tables before. I think this was in, we have seen something like this in the brine analysis and when we were doing the Olympus production. But when you go to the report for the Olympus reservoir, you will find a different table here, or an additional table here that is called saturation details. So this table has 5 columns. The first column says the solid that was selected to be in equilibrium with the brine at reservoir conditions. Then we have the inflow, what the software used to reach that saturation. This was the initial amount of calcium carbonate before saturation, and this is the initial amount of barium sulfate before saturation. Then the software had to add a specific, like had to increase the amount of calcium carbonate to reach saturation, and these are the values. And this 5th column is the difference between the final and the initial values. So what this last column is telling me is that the software added 102.7 milligrams per liter of calcite or of calcium carbonate to the water to reach saturation, and 1.52 milligrams per liter of barite or barium sulfide to reach saturation. Down here is just the inlet summary telling you how much mass you enter in gas and in brine and in gas, the total amount of mass, the conditions of the at reservoir conditions here, temperature and pressure, the phase properties. You have the properties of the liquid, the properties of the vapor, and you'll see a 3rd column that is a solid. But really, this column basically can be, it's just there. You'll see that the amount of solids that are formed is minimum or null. And the reason why is because since we are saturating, the software is making an assumption that a small crystal of calcite and barite form. Because if we are calculating saturation, we have to form that first crystal of that mineral in order, because that is indicating saturation. So that's why you're seeing this solid tab here, but in reality, you are not having solids. It's just the solution is is saturated with the minerals. And then you have the pre and post scaling tendencies, and what we have done in this calculation is that now barite is in equilibrium with the brine, and calcite is also in equilibrium. So now you see that the pre-scaling tendencies are exactly 1, because that is how we define them. The other thing that I want to point out here is the brine composition. Yes.
I have one quick question. In this type of analysis, why would you want to saturate with minerals? Like if you think of the production, what information, like what type of scenario in which you would want to saturate with these minerals?
Right. So you would, one of the reasons is because at reservoir conditions, you assume that the brine or the fluid is at equilibrium, right? And at equilibrium means that if you are having some minerals in cementing materials that are in contact with this fluid, and they will be at equilibrium, and that means that you will have a saturation ratio equal to 1. I don't know if that makes sense. So Yes, you are under equilibrium conditions. So this would be an ideal starting point, because these reservoirs have been for so long under equilibrium or at equilibrium, and the fluid had that time to be at equilibrium with these minerals. So we would assume that those minerals are saturated in that brine. Additionally, when I was showing you here,
But you're mixing the brine with the gas, right? To see what is the saturation between those. And then you're adding additional minerals that would come from where? Like from the formation?
yes,
Okay.
from the formation. So
Diana, there's also a question in the chat I think goes well with the Valentina's question from Joe. And is there a way to use the rock mineralogy data and saturate the brine and gas with it?
oh, yes, definitely you can do that. Rather than so instead of putting here the reservoir conditions, you can put whatever conditions that you want here. It could be separator, it could be it could be the bottom hole, it could be wellhead, it could be any conditions that you know. So you could do that. Simulating frac water adding to the rock, and what would the water composition? Simulating frac water adding to the rock, and what would the produce water composition? Yes, we can also do that. And in fact, I have an example, Joe, for that water. Actually, it's with seawater, but you can also do that. We will do that example next class for to see how it changes the scaling tendencies when you are adding another water. Okay, so go back to your question. I think it was Valentina. Yes, so you could have not initially you don't need to do this. You don't need to saturate, but you know that there is a reservoir. You know that it is in contact with those minerals at reservoir conditions. And when I was showing you before, I added this. They were almost near saturation. One was like 84% near saturation, and the other one was 63%. So it made sense to saturate it with those minerals. And another reason for doing that saturation is because you will account for the maximum scale risk that you could possibly have. So you probably, maybe in here I'm being like super, I want to account for everything. So I am saturating with these solids for that reason as well. So what I will show you here is that, yes, the software added this much to saturate the fluid with these minerals. And you will see that the changes in the composition of barium, for example. So initially we entered a barium amount of, let's see, what is barium? 5 milligrams per liter. And after saturating, we see that the barium amount is 5.6. So it changed, but it didn't change a lot. So it makes sense to saturate with these minerals to account for the maximum scale risk during production. I hope I answered your question with this. Okay, so next, now that we are happy, we say, okay, this is a representative reservoir fluid. Is in equilibrium with the minerals at reservoir conditions. So what I can do is produce this fluid. Okay, so we can go back to the Olympus production and go back to design, go back to inlets. And rather than entering this brine and gas individually, what we can do is let's select this and let's delete it. And what I can do here is to bring the whole fluid that was recreated at Olympus Reservoir. So we are going to select whole fluid and then select the option Olympus Reservoir. And you don't even need to enter any mass of gas or brine or anything, because we have already entered that in our respective analysis. Okay, so we bring the saturated fluid, the whole fluid, here just by bringing the whole fluid, and the software will automatically add up the production rates for us. So if we go to conditions, we should have the previous conditions that we have worked with here. And for solids, we will need to select the standard solids. And then we're ready to calculate. This will not be different from what we have analyzed before in this plot here. So any other questions while this calculates? This will not take a long time, but now you will see something different here, right? Notice that the barite and the calcite values at reservoir conditions start at a saturation ratio of 1. Let me put the default plot here just so that everyone sees the same in case you don't have the plot template manager, pre-scaling, and solid plot. So in here, what you're seeing is it started at equilibrium or at saturated conditions because we defined it that way. And then we'll see the scaling tendency, the pre-scaling tendency of barite, how it increases as temperature decreases. And that the calcite scale, it stays more or less at saturation values, 1, 1, 1. And at the choke conditions, then it starts going down. So it's no longer saturated. So we don't have scaling problems here in these two locations. And if we go to the pre-scaling and solids plot that we created, in here we'll have the amount of solids of calcite and barite that will form at each location. Again, this is the condition that we are accounting for saturation at reservoir. Maybe if you compare it to the previous calculation that we had, maybe it doesn't change that much. But in here we are being extremely conservative, and that's why I did the saturation with those minerals at reservoir. And these would be the values of solids, of the amount of solids that precipitate out. So for calcite, we'll have in the wellhead an amount of 21 milligrams per liter that precipitating out. And for barite, this will be the amount. Oh no, this is not the amount. It will be this blue one here. 6.86 milligrams per liter at the separator will be the maximum solid precipitation. Okay, so that is how we do the Olympus reservoir. Going back to the question, is there a way to use the rock mineralogy data and saturate the brine and gas with it? Yes, you can see, like I mentioned before, you don't need to use, in this case, we were simulating the reservoir, but you can simulate any other condition here and saturate it with the solids. And just put the different conditions, temperature and pressure that you have. Okay.